Hello students. Now already I finished the similarity. Now I am going to start the chapter 17 circle. First I am going to tell about the circle. Here this is O is the center, OA is radius, AB is the diameter. AB is diameter, it is passing through O, the longest chord also, and double the radius is diameter. And the CD is the chord. The longest chord is the diameter. Next, CPD. This is an arc. You should know all the terms. Then you can do these sums in the circle chapter. Then CPD. Now the portion covered with this arc and this chord. This portion is segment and it is called minor segment, and this full other area major segment. Now the theta I mentioned here, the arc subtended at the center. This is theta. That is the angle subtended by an arc at the center. Now the area covered with two chords and one arc is called the sector, and it is called the minor sector, and the remaining portions are major sector. Okay, now coming to this figure, here this is the tangent. Tangent touches the circle in only one point. Always the radius is perpendicular to tangent. And this is the secant. It intersects the circle in 2 points A and B. It is a line. This is also a line. You know the definition of line, line segment and ray. The line has no end point. Line segment has two end points. Ray has only one end point. Okay, coming to this picture, here this is called the concentric circle. Definition of concentric circle, they have the same center but the radii are different. This is a smaller one, little bit bigger and bigger. The radius is different and the center is same. Then the circles are called the concentric circle. Coming to the concurrent circle or equal circle. Now the 3 centimeter circle, this is also 3 centimeter circle. Radius is 3 centimeter. Center is different but radius is same. These two circles are called the concurrent circle or equal circle. And circle have same radii and different center. Coming to the circumcircle. Now this is a trapezium or quadrilateral. Around that you are drawing a circle. This circle is called the circumcircle. If the circle is inside, then it is called the incircle. This is called incenter. This is called circumcenter. All you know the construction also. You know how to construct the incircle and circumcircle. Okay. Now these points you have to remember. Already in your 9th standard you learned the theorem. Based on that, sometime we are using this theorem also in the 10th standard. That is why I am giving one, the line segment drawn from the center perpendicular to the chord, bisect the chord. Second one, a line segment joining the center and the midpoint of the chord perpendicular to the chord, and there is only one circle you can draw through 3 non-collinear points. Equal chords of a circle are equidistant from the center. Suppose the chords are equal, distance are equal. Chords of the circle equal distance of the center are equal. Suppose the distance are equal, then the chords are equal. All this theorem already you learn in your 9th standard. Now for the 10th standard, this is theorem number 1 and it is very important. The angle which an arc of a circle subtended the center is double the angle subtended by at any point on the remaining part of the circle. The same arc, you have to remember, same arc. Subtend here angle AOB. This is the angle subtended by an arc at the center. ACB is the subtended by the same arc on the circle, any part of the circumference. So what you are going to prove, AOB is equal to ACB. That is the same arc subtended at the center is double the angle subtended on the circle. AOB is equal to 2 times angle ACB. This theorem is very important theorem. Okay, now you take this one, proof. But proof will not come for the examination, but you should know. That is why I am explaining. I am marking the numbers, then it is easy to understand. Here I mark 1, 2, 3, 4, 5, 6. Now this is the ABNR subtended at the center, ABNR subtended on the circle at C. Now join CO and produce till D. Now angle 1 is equal to angle 3 plus angle 4. Reason, the exterior angle is equal to sum of interior angle. But OA is equal to OC. Therefore 3 is equal to 4. Similarly 5 is equal to 6 adding 1 plus 2 is equal to 1 is 3 plus 4, 2 is 5 plus 6. And in the place of 3, you can write 4 because 3 is equal to 4. In the place of 5, you can write 6 because 5 is equal to 6. So 2 times 4 plus 6. So 1 plus 2 represent AOB and 4 plus 6 represent ACB. Therefore, angle AOB is equal to 2 times angle ACB. So angle subtended by an arc at the center double the angle subtended by the same arc on the circle. That is the remaining part of any point on the circle. Now this figure, see now, just for example, I draw the figure AOB. The same arc here subtend. So AOB is equal to 2 times angle APB. Coming to this figure, here this angle here less than 180. But this angle is more than 180 reflex angle. So AOB is equal to 2 times angle APB. Okay, coming to the theorem number 2. Angle in the semicircle of a circle are equal. Angle in the same segments of a circle are equal. So what is angle in the same segment? Now this is a chord. This is the major segment. This is the minor segment. Already I discussed about the segments. Okay, this portion, the same or subtended C, the same or subtend here. So you have to prove angle C is equal to angle D. Now construction, join AB with O. Now according to the previous theorem, angle AOB is equal to 2 times angle ACB or ACB is equal to half of angle AOB. Similarly, ADB is equal to half of angle AOB because this is an arc subtended at the center, same arc subtend here, same arc subtend here. So this is also half of AOB, this is also half of angle AOB. Therefore, ACD is equal to ADB. So angle in the same segments, that is in the major segment. Suppose you are taking minor segment, the same proof. Now this angle, EF. So AEB is equal to AFB. The end point should be same. You have to remember. Okay. Coming to the theorem number 3. The angle in the semicircle is right angle. See here, this is a semicircle. What is semicircle? The diameter. The diameter divide the circle into 2 parts. Each is called the semicircle. Now you are going to prove angle ACB is equal to 90 degree. You know AOB is a straight line. That means 180 degree. So according to the same theorem, in this half it should be. Therefore ACB is equal to 90 degree. Therefore angle in the semicircle is 90 degree. Coming to the theorem number 4, before that I want to explain about the cyclic quadrilateral. What quadrilateral, all of you know. The four-sided closed figure. And a circle. Cyclic quadrilateral means all the vertices lie on the circle. Then it is called a cyclic quadrilateral. A vertices of a quadrilateral lie on the circumference of the circle. Then the quadrilateral is called the cyclic quadrilateral. Based on that, next theorem. In this, what is the theorem? The opposite angle of a cyclic quadrilateral or supplementary. What is supplementary? 180 degree. That means in this figure, you want to prove angle A plus angle C 180 degree, B plus D is equal to 180 degree. Now coming to this figure, ABCD is a cyclic quadrilateral and A, B, C, D are called concyclic points. The vertices are lying on the circle. Okay, now join with A and C, join with the center. So now I am marking it as 1, 2, 3, 4. You know angle 3 is equal to half of angle 1. Based on the same theorem, that is, theorem is very important. Angle 4 is equal to half of angle 2. So angle 1 plus angle 2, 1 plus angle 2 is equal to 2 times angle 3 plus angle 4, or angle 3 is equal to half of angle 1, angle 4 is equal to half of angle 2. Therefore, angle 3 plus angle 4, half of 1 plus 2. What is 1 plus 2? It is a complete angle, 360 degree. Therefore, you can write angle 3 plus angle 4, half into 360, 180 degree. What is 3? 3 is D. B is 4. So, angle B plus angle D is equal to 180 degree. You know, sum of 4 angles of the quadrilateral 360 degree, A plus B plus C plus D 360. But you know B and D are 180. Therefore, A plus C is equal to 180 degree. Therefore, in a cyclic quadrilateral, sum of opposite angles supplementary. Coming to the last theorem, theorem number 5. the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. But in triangle what? Exterior angle is equal to sum of opposite interior angle. Here in cyclic quadrilateral, exterior angle is equal to sum of opposite interior angle, no sum of, only opposite interior angle. Okay, now I am taking the cyclic quadrilateral. The one is the exterior angle. You want to prove 1 is equal to 3. Okay, now this is a straight line. 1 plus 2 is equal to 180 degree. Next, you know 2 plus 3 is equal to 180 degree. In a cyclic quadrilateral, sum of opposite angle 180 degree. Comparing it, 1 plus 2 is equal to 2 plus 3 is equal to 180 degree. Common 2, therefore 1 is equal to 3. Exterior angle is equal to opposite interior angle. So it is about the cyclic quadrilateral, and few important results in the circle. Equal chords subtend equal angle at the center. Suppose the chords are equal, angle subtended at the center are equal. AOB is equal to COD. Next one, here this is an equilateral triangle. Equilateral triangle, each angle 60 degree you know, and all the three sides are equal. AB is equal to BC is equal to AC. Therefore, AOB plus BOC plus CA, 360 by 3, 120 degree. So, equilateral triangle, each side subtend how much angle? 120 degree. Coming to this one, suppose you are taking FE is the side of the square or hexagon I am taking. So hexagon means how many sides? 6 sides, isn't it? So 360 by 6, 60 degree. Suppose CD is the side of the regular pentagon. Pentagon means how many sides? 5 sides. So 360 by 5, 72 degree. So pentagon each side, these are all regular figures, not irregular pentagon, regular pentagon. Each side subtended at the center. This each angle of pentagon is different. Angle subtended at the center is different. Angle subtended at the center by the regular pentagon is 360 by 5, 72 degree. And suppose AB is the side of a square. So 360 by 4, 90 degree. And last one, suppose the AB ratio CD is 7 ratio 5. This is 7 times this is. Then angle at the center also, what is the ratio? 7 ratio 5. Suppose AB is equal to 2 CD, then AOB is equal to 2 times angle COD. Suppose ABCD connection is given, AB 2 times CD means definitely the angle also 2 times angle COD. All these theorems are important theorems, but the proof will not come from the for the theorems. Only the sums based, that especially the numerical sums will come, students. So in the class I will explain all the sums, and through PDF I will send all the sums also, students. So revise all the theorem and come prepare and come to the class. Thank you.